There are roughly 165 million rivers on Earth. Most move quietly through the world, carrying water from one place to another, feeding cities, fields, forests, and finally surrendering themselves to the sea. We think we understand rivers. We swim in them, fish from their banks, build bridges across them, and raise dams to control their power. In the human imagination, a river is supposed to be familiar, useful, gentle, and safe. But hidden among those millions of waterways are rivers that seem to challenge everything we think we know. Some appear to vibrate. Some carry not ordinary water, but deadly acid. Some run clear through underground darkness. Others are so dangerous that life itself cannot survive near their banks. These places are not inventions from legend or science fiction. They exist today, marked on real maps, with coordinates precise enough to enter into a GPS, though not every one of them should ever be visited. One of the strangest lies deep in the Peruvian Amazon, a river whose very existence once sounded impossible. It is called Shanay Timpishka, a name from the language of the local Ashaninka people, often translated as heated by the heat of the sun. Yet the truth may be far more mysterious than the name suggests. For more than 3.5 miles, this river runs at temperatures between 158 and 212 degrees Fahrenheit. Steam rises from its surface. The stones beneath the water are coated with heat-resistant bacteria. Any animal unlucky enough to fall in can die within seconds. Local people have long spoken of small creatures slipping into the current: lizards, geckos, snakes. The end comes quickly. The eyes are affected first, the white tissue tightening as the animal is blinded before it can understand what is happening. Then the skin begins to fail, then the muscles. In moments, what was once alive becomes a shapeless mass carried away by the boiling flow. To those who live near it, Shanay Timpishka is not simply a river. It is a boundary between life and death. For generations, stories of this place were dismissed by outsiders. A boiling river in the middle of a rainforest, far from any known volcanic system, seemed to violate common sense. Hot springs usually belong to volcanic regions, yet the nearest active volcanic zone is hundreds of miles away. The idea sounded absurd until 2011, when a young Peruvian geographer named Andrés Russo, raised on his grandfather's stories of the river, went into the forest to see it for himself. He found that the legend was real. The river boiled, but not because of volcanoes. After years of study, Russo reached a startling explanation. The water may begin as rain, falling far from the river, then sinking deep into cracks in the earth, where hidden heat warms it before forcing it back to the surface. Even now, the river stands as a reminder that the world beneath our feet is far stranger, older, and more powerful than we often dare to imagine. This superheated water rises back toward the surface through a hidden system of geological fractures, emerging not as a spring, but as an entire river. Shanay Timpishka is, in a sense, a giant natural kettle. Cold rainwater descends into the earth, is heated in the darkness far below, and eventually returns in a boiling current. The journey may take many years. The water steaming through the river today may have fallen as rain decades ago. For the local tribes, the boiling river is not merely a geological wonder. It is sacred ground. Shamans use its steam in ceremonies and its water in traditional preparations. They believe the river carries a supernatural force, and that a great serpent or dragon spirit dwells beneath its depths. Andrés Russo approached the place as a scientist, with instruments, measurements, and skepticism. Yet even he has admitted that when you stand on the bank, Surrounded by rising steam and the thunder of boiling water, it becomes difficult not to feel that something ancient is present. Here, science and mythology do not cancel each other out. They meet in the same burning mist. Rousseau later installed temperature sensors along the river and found that its heat changes with the seasons and rainfall. In the dry season, parts of the river reach their highest temperatures, close to 212 degrees Fahrenheit. In the rainy season, cooler water dilutes the current, bringing some sections down to roughly 140 to 158 degrees Fahrenheit. But even then, the river remains dangerous enough to cause severe burns within seconds. Local people know the safe places, small tributaries where hot and cold water mingle, forming natural pools near 104 degrees Fahrenheit. There, people bathe, wash clothing, and even cook food directly in the river. Yet a single step away, the water can return to a deadly boil. Chronicles matters to science because it challenged long-held assumptions about geothermal activity. For years, a boiling river of this scale seemed impossible without a nearby volcano. But the river suggests that deep fractures in Earth's crust can allow rainwater to descend far enough to be heated by buried rock, then forced back upward as a scalding current. And if that is true, then perhaps Chronicles is not alone. Similar rivers could be hiding wherever deep cracks, heavy rainfall, and forgotten terrain come together. How many lie unseen in the Amazon, the mountains of Central Africa, or the wild forests of Borneo? We do not know. But if Chronicles kills with heat, the next river kills by another force entirely. In southwestern Spain, the Rio Tinto flows through Huelva, staining the landscape in colors that look almost unnatural. The river runs a deep, unsettling red, sometimes shifting toward orange, while its banks glimmer with mineral crusts in yellow, purple, and black. It is one of the strangest landscapes on Earth, and also one of the most poisonous. The Rio Tinto has a pH close to 2, roughly comparable to stomach acid. Heavy metals dissolve into its waters, including iron, copper, zinc, arsenic, and cadmium. No fish, no frog, no crayfish can live there. By ordinary standards, the river seems dead. Its red color comes from dissolved iron, oxidized by the acid, until the water appears almost like liquid rust. But the deeper question is not what gives the river its color. The deeper question is where the acid comes from. The answer lies underground. The Huelva region is rich in sulfide ores, minerals that contain sulfur and metals locked together in the stone. When those ores meet water and oxygen, a chemical reaction begins, producing sulfuric acid. This process, known as acid drainage, can happen naturally, but here it has been greatly intensified by mining. Human beings have worked these deposits for nearly 5,000 years, from Phoenician and Roman times to the Industrial Age. With every new tunnel, every exposed layer of sulfide rock, the reaction has been pushed further. In that sense, the Rio Tinto is a river humanity has been altering for millennia, often without understanding the full cost. And yet, in this place that appears lifeless, something extraordinary survives. Not fish, not frogs, not familiar river creatures, but microorganisms, bacteria, and algae that do not merely tolerate the acid. They flourish within it. They feed on dissolved metals, draw energy from chemical reactions, and paint the riverbed in strange layers of red, green, and purple. For NASA scientists, the Rio Tinto has become one of the closest earthly mirrors of conditions that may exist on Mars. The red planet is colored by iron oxide, and beneath its surface, some researchers believe acidic, metal-rich water may once have flowed, or may still remain hidden in some form. If life exists there, or ever existed there, it may resemble the microscopic survivors of the Rio Tinto. For more than 2 decades, researchers have used this river as a natural laboratory, testing ideas and instruments meant to search for life beyond Earth. But the Rio Tinto is also a warning. Its history is a record of human hunger for the minerals buried below. The Phoenicians came for silver. The Romans sought copper and gold. In the 19th century, British and German companies turned the region into an enormous mining landscape, removing millions of tons of ore. Even the river's name became a global symbol, carried by one of the largest mining corporations on Earth. The irony is difficult to ignore. A name born from a poisoned river now travels the world, tied to an industry that has too often left other waters wounded behind it. The Rio Tinto is not merely a strange river. It is a mirror held up to 5,000 years of human ambition. Across that long history, we but into silver, copper, gold, and iron from the earth, and too often left behind acid, rust, and silence. But the next river leads us into an even stranger realm, because it does not flow across land at all. It flows underwater. In 2010, British scientists identified a complete river system at the bottom of the Black Sea, with channels, banks, floodplains, and even waterfall-like drops. It moves along the seabed at a depth of about 115 feet. In some places, it stretches up to more than half a mile wide and over 100 feet deep. If this river flowed on land, it would rank among the largest in Europe, even larger than the Rhine. At first, the idea seems impossible. How can a river exist beneath the sea? The secret is density. The water in this hidden current is much saltier than the surrounding Black Sea water, making it heavier. It enters from the Mediterranean through the Bosporus Strait, sinks downward, and begins to travel along the seafloor. Once there, it follows carved channels much like any river on land. The difference in density is strong enough to create banks, currents, eddies, and powerful whirlpools. The only difference is that all of this takes place beneath another body of water. Divers who have entered similar underwater rivers describe the experience as almost unreal. You descend through clear water, then suddenly encounter what looks like the surface of another world below you, darker, murkier, and moving with its own current. Reach into it, and the flow pulls your hand sideways. It is a river within a river, water hidden inside water, a reminder that even the ocean has secret landscapes we rarely imagine. These underwater rivers are not unique to the Black Sea. Similar systems have been found in places such as the Gulf of Mexico, near Australia, and in the Caribbean. But the Black Sea River remains one of the largest and best studied. It plays an important role in the deep sea environment, carrying oxygen and nutrients along the seabed and helping form unusual communities of organisms that live between layers of water. For geologists, it also offers a key to understanding how underwater canyons and sediment basins are shaped. The lesson is profound. The seafloor is not still. It is carved by movement, just as valleys and plains are carved on land. The water simply flows beneath other water. Scientists discovered this hidden river using advanced depth measuring instruments able to distinguish between water layers of different density. When the first images appeared, the data showed unmistakable features: a winding riverbed, floodplains, banks, and old abandoned bends separated from the main flow. In every meaningful way, this underwater river behaves like an ordinary river. It meanders, erodes, transports sediment, and builds a delta where it spreads into a plain. If there were trees on the Black Sea floor, it would wear them down. If there were bridges, it would weaken them too. Water remains water, whether it moves beneath sunlight or beneath the sea, and it obeys laws older than civilization itself. It took humanity thousands of years to learn that rivers do not only exist where we expect them. Some flow beneath the sea. Some boil in the forest. Some burn with acid. And the fourth brings us to Africa, to a place dangerous not because of heat or acidity, but because of what its waters can do to the living body. In northern Tanzania lies Lake Natron. Technically, it is a lake, fed by rivers and springs, but the waters entering it help create one of the strangest natural environments on Earth. Lake Natron contains such extreme alkalinity that animals that enter it can appear to turn to stone. Not instantly, not by magic, but through a process chilling enough to look like a scene from a nightmare. The water can reach a pH between 10.5 and 12, similar in harshness to an ammonia solution, and in some places, temperatures climb to about 140 degrees Fahrenheit. The mineral that gives the lake its name, natron, is sodium carbonate washed from the surrounding volcanic rocks. This is the same kind of mineral once used by the ancient Egyptians in mummification. And in a strange way, the lake performs a similar act on the animals that die there. It calcifies and preserves them. Photographer Nick Brandt, while working along the shores of Lake Natron, found dozens of birds and bats preserved in eerie detail. They looked less like remains than sculptures, frozen in natural poses and coated in pale mineral crust. Some birds appeared perched, with wings spread. Others seemed suspended as if still trying to fly. Another looked as though it had tried to rise from the water, only to be claimed by the lake itself. The mechanism is simple and merciless. Birds, especially migrating flocks, mistake the reflective surface for ordinary water and land on it. The alkaline water attacks their skin and feathers, enters the tissues, and over time, their bodies become mineralized. Wind and waves then carry these hardened forms to the shore, where they may remain for years, even decades, like monuments shaped by nature's darker hand. This is not folklore. Brandt's photographs spread across the world and became some of the most haunting wildlife images of the modern era. And yet the lake holds a paradox worthy of nature itself. This place, deadly to so much life, is the most important breeding ground for lesser flamingos in East Africa. Around 2.5 million gather on the salt islands near its center. The same alkaline waters that kill many creatures protect them from predators. Flamingos endure what others cannot, with tough, scaled feet and specialized glands that help filter salt and alkali. Here, death becomes a shield, and the lake that preserves the fallen also shelters the fragile future of a species. Lake Natron, this lake of death, is also a nursery for millions of birds. Nature, as always, plays by rules older and stranger than ours. But the lake is not dangerous only to animals. People who have tried to cross its shallow waters on foot have suffered severe chemical burns. The alkaline water can begin damaging skin within minutes, turning a beautiful surface into a trap. The Maasai people who live near its shores understand the lake's power and keep a careful distance. They collect natron from the dry lands around it, using the mineral for practical purposes such as treating hides and seasoning food, but they know better than to step into the water itself. From above, pilots describe Lake Natron as one of the most beautiful sights in Africa. Its surface shifts from red to pink to orange, depending on algae, minerals, and temperature. White salt islands create strange patterns across the water, like abstract paintings laid upon the earth. Beauty and death joined again in one place. Scientists worry about the lake's future. Plans have been considered more than once to build a sodium carbonate plant near its shores, and environmentalists warn that such development could disturb the delicate balance that supports East Africa's greatest flamingo breeding ground. For now, those plans remain stalled, but the danger has not disappeared. The harshest places on Earth are often the most fragile, and what looks indestructible may be one careless decision away from collapse. The fifth and final river brings us to a different kind of mystery, not one of chemistry or heat, but of physics and human will. In Illinois, the Chicago River performs one of the most unnatural acts a river can perform. It flows backward. Its course was artificially reversed, turning the river away from Lake Michigan and toward the interior of the continent. Before 1900, the Chicago River flowed into Lake Michigan, the very freshwater source that supplied the city's drinking water. But Chicago was growing fast, and its waste was being dumped into the same river. Sewage, industrial discharge, and slaughterhouse remains from the city's vast meatpacking industry. The result was predictable and devastating. The water became contaminated, and outbreaks of diseases such as typhoid and cholera took many lives. So engineers chose a radical solution. Rather than allow polluted river water to continue entering Lake Michigan, they would force the river to change direction. The waste would flow away from the city's drinking water toward the Illinois River, then onward into the Mississippi system. For Chicago, it was salvation. For communities downstream, it became another burden carried by the current. The project was enormous. Engineers built the Chicago Sanitary and Ship Canal, cutting through the divide between the Great Lakes Basin and the Mississippi River Basin. The canal stretched roughly 25 miles and took 8 years to complete. In the end, humanity did something almost mythic. It commanded a river to turn around. Thousands of workers, hundreds of machines, and millions of cubic yards of rock were required to make it happen. Then, on the 21st of January 1900, the locks were opened, and the Chicago River began to flow backward. For thousands of years, its water had moved east into Lake Michigan. In a single act of human engineering, that ancient direction was reversed, and the current was sent west toward the Mississippi River system. It remains one of the boldest hydraulic engineering projects ever attempted. Humanity looked at a river and, in effect, commanded it to obey. Naturally, the cities downstream were not impressed. Street. Louis, sitting along the Mississippi, sued Chicago, arguing that the city was sending polluted wastewater toward its own drinking supply. The case reached the United States Supreme Court, and in 1906, the court sided with Chicago, stating that there was not enough evidence proving Chicago's sewage was causing disease in street. Louis. The ruling was controversial, but it secured the Chicago River's strange new identity as one of the only major rivers in the world forced to run backward. Today, the river still flows in that altered direction, and Chicagoans speak of it with a kind of ironic pride. Along the riverbank, signs remind visitors that here, the river flows upstream. But the consequences of that decision have not ended. By connecting the Great Lakes Basin with the Mississippi River Basin, the canal opened a pathway that nature had never intended. Through that artificial corridor, invasive species began moving between ecosystems that were once separate. The greatest modern threat is the Asian carp, a large, aggressive fish that has disrupted parts of the Mississippi system and continues pushing north toward the Great Lakes. If it enters those lakes in large numbers, it could damage a fishing industry worth billions of dollars. To stop it, electric barriers have been installed in the canal, sending pulses through the water to repel the fish. It sounds almost unreal, yet it is true. An electric wall now guards an entire lake system from the consequences of a decision made more than a century ago. The Chicago River is proof that every human victory over nature carries a hidden cost. Instead of ending pollution at its source, Chicago changed the direction of the water. Instead of healing the river, it moved the wound somewhere else. It was a masterpiece of engineering and an environmental warning, fused into one story. Nature creates boiling rivers, acid rivers, underwater rivers, and deadly alkaline lakes. But only humans could take an ordinary river and make it flow backward, simply because it was more convenient. In the end, these rivers remind us that water is never merely water, and a river is never simply a line moving across a map. The boiling river of the Amazon, the acidic Rio Tinto, the hidden current beneath the Black Sea, the deadly beauty of Lake Natron, and the reversed flow of the Chicago River each reveal a different face of the earth. Some nourish life, some destroy it, some sleep beneath the ocean, and some carry the unmistakable scar of human ambition. Together, they seem less like accidents of geography and more like the planet's living bloodstreams, carrying memory, warning, and wisdom older than any civilization we have built. Perhaps rivers possess something like a soul. Or perhaps they are expressions of a higher intelligence that shaped nature with laws so deep we are only beginning to sense them. We measure temperature, acidity, current, and depth, but machines alone cannot teach us reverence. Maps can show us where a river flows, but they cannot tell us why standing beside one can make the human heart feel small, humbled, and strangely awake. To truly understand these waters, we may need more than science. We may need to cultivate ourselves. We may need to become more honest, more patient, more ethical, and more willing to live in harmony with the greater laws of the universe. Modern humanity often tries to conquer what it does not understand. We dig into mountains, poison waters, reverse rivers, and push our problems downstream, believing that if the damage is out of sight, it has disappeared. But the earth remembers. Every river carries a record of what has been done to it, and perhaps the outer world reflects the inner condition of mankind. When gratitude fades, when restraint is lost, when respect for life is replaced by convenience and greed, even water can become a warning. So, which of these extraordinary rivers left the strongest impression on you? Was it the boiling river of the Amazon, the Red River of Spain, the underwater river of the Black Sea, the deadly Lake Natron, or the River Chicago forced to run backward? Share your thoughts in the comments, and subscribe for more stories exploring the hidden mysteries of our Earth.